So does anyone want to see?
Me, like, try, so first, do, 1, 2, 3, and 4 E on the E row,
1, 2, 3, and 4,
and then 3D,
and then 3D. This.
and then, 5 C, D, and E,
5, C, D, and E. Yep.
and then 4 D and C,
Mm-hmm.
and then, 1, 2, and 3 C. No,
Oh.
C.
Oh shit. Sorry. So it was like this and then like this.
Mhm.
Sorry about that. So 1, 2, and 3 C.
And then 1 and 2 D.
1 and 2 D.
And then 1, 2, and 3 A, and 1, 2 B.
Mm-hmm.
And then 4 and 5 A, and 4, 5, and 3 B.
Nice. So like let's think about a sort of strategy to do this, right? Because notice how you're trying to notice something about each of these districts. Like, do we see something about how most of these districts are grouped?
They're like the L, but like it's kind of like a square with an extra one on top or
Okay.
bottom. Like,
Yeah, so that is an astute observation. But like let's think about how like the proportions of green and yellow in each of these. Because if we look at this one, this one, this one, we have 3, 3, 3, 4, and 1. So like, does anyone notice a pattern or like what's most commonly used in this case?
Like 3
Yeah.
greens.
Yeah, so yeah, that's exactly correct. We use 3 greens, generally speaking, because in this one we use 4, but I mean we could also use 3 if like we just grouped it differently. But we generally want to use 3 greens, and something that is interesting to think about in terms of voting is that not every vote like matters. Because for instance, in this case, these 2 yellow votes, they don't do anything. Because for example, like these votes are sort of wasted, even though they contribute to the total amount of votes, but they don't contribute to the victory of yellow. They don't contribute to any of yellow's seats. So if you're green, do you think we want to minimize or do we want to maximize the amount of wasted votes for yellow?
What?
Okay, so yeah, sorry, maybe if I didn't make this clear, but like let's talk about a sort of idea called of wasted votes. So do you see how these 2 yellow votes are actually wasted because they don't like contribute to the yellow's victory in the end, right? For instance, even though we have 1, 2, 3, 4, 5, 6, 7 yellow votes here, they don't actually do anything in the end, because if they were, say, replaced by green, the result would be the same. Do you see how that works? Like these yellow votes do not help to give the yellow team or like the yellow party a seat or like allow them to win a district. Do you see how that sort of works? Right, so if you don't understand, I think it would be great to ask like any questions about what kinds of things make sense. Oh, okay. So people do understand. Okay. So basically, when you want to what you want to do as green to win as many votes as possible, do you think we want to minimize or maximize them? Minimize the amount of votes that yellow wastes, or maximize the amount of votes that yellow wastes, or a maximum number of wasted yellow voters, basically. Yeah, that's kind of. Seven? Okay. So, yeah, so those are the, so Olivia says that we want to minimize. So remember that we're actually working for green. So it would be correct to say that green will want to minimize the amount of votes of green votes that are wasted. But for example, green actually has a wasted vote here. This vote right here does not actually do anything in this case, right? Because it's like, it's not like contributing to helping the green members win. However, for green to win, they want to, okay, I was asking, am I wrong? So, yeah, so for green to win, they want yellow to waste as many seats as possible, waste as many votes as possible, right? Because if yellow wastes a lot of votes, then green can get more districts. So for example, so yellow wants to maximize the number of votes that yellow wastes. And in order to do that, they want to keep districts as close as possible. So for example, in this case, we have 3 votes and 2. But if we say, so we are talking about green's view. Green wants to maximize the number that yellow wastes. So you want to maximize the number of votes that your opponent wastes and minimize the number of votes that you waste, right? Does that make sense? Okay, so that means that we have yellow vote. That means that in this case, we want, so, oh, okay. So, okay, that might have been a bit of a confusion. But in order to minimize these votes, we want to in order to maximize the amount of votes that yellow wastes, we want to make sure that these elections are as close as possible, so that all of these yellow voters will basically be cut off in a green dominated district. But we can also think about another kind of wasted vote. And another kind of wasted vote is, say, this vote right here in yellow. Because if you think about it, if this vote right here switched to green, yellow would still win. And this vote right here, it literally, it doesn't matter, because even if it was green, yellow would still win this district, and the district would yellow would still get a seat. So this is actually a wasted vote for yellow. Does that make sense to people? Yeah. So this is how we can sort of group these things into like just wasting all of the other parties' votes, and how we turned a sort of small majority, like green isn't winning by that much, they're winning but not that by that much, into a huge majority where green is winning 4-1. Kind of. Sorry, what do you mean by kind of?
You just said kind of,
Oh,
but
okay, maybe that's my weird way of talking because I don't know. I say kind of a lot, but so like yeah, so green is winning. It's not like winning that much. That's what I was saying. But we have made it win by an enormous amount. Now it's winning 80% instead of before where it was winning by like a bit more than 50%, not around 60, 70%. So we have just boosted green and allowed it to win so many more votes. Yeah. So why don't we move on to map 3 and see how these wasted votes come into play? Because remember, we want to maximize the wasted votes. Kind of says wait.
Wait,
Mhm.
aren't
Mhm.
isn't like don't you like still doesn't green still win with 3 districts? So isn't that other district votes also technically wasted?
I mean, I guess, but okay, so it's well, like first of all, green would obviously prefer if they have a lot, but this is a really good way to think about this because this is sort of the idea in presidential elections. But in a like congressional election, this is only one state, right? This is not the entire thing. So for example, there are a bunch of other like sort of situations taking place all around the country, all around America. And all of these people get elected to Congress. So the more people, the more districts this state has, the more powerful green will be in Congress. So it's not just about achieving a majority in the state. It's you can also talk about achieving a majority in the entire thing. So for example, in the North Carolina example I just mentioned, Republicans will still win even if they only had like a slim majority. But because they have such a large majority, they have like such a large amount of seats, then they can easily take over Congress, have a lot more people in Congress so that they have more power. So so you're right. But in terms of like, if we take this one step further, then we would see that these votes are not in fact just merely wasted. But that's a very interesting way to think about it. Green has 14. Yep. 14 against 25 is, yeah. So green has 14 versus yellow's 11, which isn't too big of a difference, right? Yeah. So as Olivia said. And if we actually do the calculations, we can see that green has 56% of the vote. Yeah, which isn't that much, but now it has 80% of the seats, which is actually quite similar to the North Carolina example I mentioned earlier. So do you guys want to move on to the third map or like the third example of gerrymandering? Yes, okay. So why don't we have a try on this one? I don't care, you're the teacher. Okay. Well, I believe in democracy, so. So does anyone want to try this one?
Me?
Ooh, E? Which E?
Me.
Oh, me. Oh, sorry, I have terrible hearing.
Couldn't you just go like in columns all the way and couldn't you still win?
Hmm?
Couldn't you just go in columns?
Like this?
Yeah.
Yep, you can. But if we, yeah, so if we look at this, we can see the number of wasted votes that yellow has is quite a lot. Like all of these votes here are wasted. And the way as the way Kevin sort of wasted all of yellow's votes was by, first of all, compacting. It was mainly about splitting the votes up into all of these yellow votes, splitting them up into smaller sections that can then be dominated by green. So it's sort of like divide and conquer. And then all of the leftover votes that yellow should have gotten, he just compacted them into this one. In this one, yellow doesn't really waste many votes from in this district, but they waste a lot of votes on the other ones. But later we will probably see how compacting yellow's votes into one district will help. So let's think about, actually, I don't think this one's that interesting, but let's think about this one. Why don't we look at this one? So does anyone want to try to make green win? And also remember, they also have this impossible button here, just in case you think it is not possible.
I want to try.
Yeah, okay, cool.
1, 2, B,
Mm-hmm.
and then 1, 2, 3, C.
1, 2, 3, C. Nice. These votes are now wasted.
Actually, I kind of think this is kind of impossible
Why do you think that?
because you can only get 1 or 2 districts
Mm-hmm.
no matter what. So I think it's impossible.
Let's see if it is impossible. Says it's possible, actually.
Um,
So yeah, so we should remember the principle of kicking out people's votes, it's not kicking out,
Oh,
wasting their votes.
so 2, 3, D,
2, 3, D.
and then 1, 2, 3, E.
2, 3, E.
And then just the whole C column.
Wait, the entire C column?
And then 3, 4, 5, A.
Mm-hmm.
And then wait, no.
Oh, whoops. Sorry about that. Yeah, so Olivia's talking about the yellow that's alone here.
Okay. Wait, but it looks like there's gonna be oh, okay. 1, B, C, and D.
1, B, C. Okay, sorry.
Wait, no. Yeah, 1, B, C, D.
Mm-hmm.
And then 2, B, C.
B, C.
And then wait, no, that's not gonna work.
Mm-hmm. Yeah,
Um,
because you're wasting these 2 green votes right
yeah.
here. So we want to also minimize the amount of votes that we waste. Yeah, that's actually quite hard when I look at it.
1, 2, 3, 4, C, and then 1, D.
Mm-hmm.
Still not gonna work. Oh wait, no. No, no.
So we can remember that how like a vote can also be wasted if it is like not required to win the district. So for instance, in this case, here, this district actually wastes one of the green votes because even if, say, I don't know, C4, this one right here was yellow, green would still win. So we are actually wasting one of these votes. So
What we could like erase that one and then put it to so 1A, so no, B, C, D,
Mhm.
and then 2, 3, C.
yeah, so now this is wasting two of yellow's votes, which is great.
And then it gets harder.
Mhm. And also remember the packing sort of idea, like packing all of yellow's votes into one district to maximize the amount of majority wasted votes that they have.
Trying to see how I can put 3 into 1. But you could erase the D and E one.
The D and E one.
Yeah, that one.
So you mean like
Yeah.
creating
Like
a new district like this, or what do you mean?
or like reset just like everything, I guess.
I think you were actually on the right track actually, but we can see.
Could pack them all in like with 3, 4, 5 E
Mm-hmm.
and then 4, 5 D.
Yeah.
Then you could do the same with 1, 2, 3 A. And then 1, 2 B. I don't know. This is really hard.
Yeah, so let's think about how we can group yellow into two pieces. So like there's actually not that many possibilities. So Olivia is saying we should use something like area or perimeter. It's an interesting idea, but why don't we can think about that. Like what do you how do you think we can use area or perimeter? Or do you have like you don't need to know you don't might not know exactly how, but you can think about like sort of like a thought process. Do you have an idea about that?
Wait, I just saw something.
Mm-hmm.
So 3, 4, 5 A.
3, 4, 5A.
Once you
Wait, isn't
reset.
isn't this already taken up? So do you
Yeah,
want to
just like
destroy this one?
reset. Yeah,
Okay, bye.
like everything.
Reset everything?
Mm-hmm.
Okay.
So 3, 4, 5 A
3, 4, 5A,
and then 5 B C.
5B, C.
and then 1 C D E,
1 C D E.
and then 2 3 E,
Oh, 2 3 E. Oops. So it's like a mirror image.
and then yes, it works. Okay. 2 1 2 A and B.
1 2 A and B. Okay, so like this.
And then 2 C,
Sorry, let me just get my charger. 2 C.
and then D E. Wait, no. So 4 5 D E,
4 5 B. Oops.
and
So
then
nice
4 C,
4 C.
and then the rest.
Dang. This is this is
Finally!
quite cool. This is so pretty. Yeah, so we can see all of these things at play because we've wasted 1 2 3 4 5 6 of these yellow ones through minority because like they're the minority in these and they don't do anything. And we also wasted 2 here in the majority by packing them together. So this is basically sort of the essence of gerrymandering and cheating the democracy. Basically packing like this and spreading or cracking for all of these other ones. So let's have a look at this one more time. And let's think about this one. You guys think this one is possible or do you think it's impossible?
It's possible.
Mm-hmm.
Just the whole 4 and 5 column.
Like this
Mm-hmm.
and like this.
And then 1 2 3 A,
1 2 3
and
A,
1 2 B,
1 2 B,
and then 3 B C,
3 B C,
and then 1 2 C,
oh, 1 2 C,
and
yep,
then 1 D,
1 D. Dang, you like symmetry.
and then the rest.
Yep. Yeah, so this is pretty crazy. We converted a 60% win for yellow into a 60% win for green through this packing. And notice how we can actually pack much better when these green things when they're separated like this. Because now it's easier to pack. So let's think about that when we're determining impossibility. So let's think about this one.
Wait, can't you just make columns or something?
Columns
Yeah.
like this,
Mm-hmm.
this, this, this. Yep. Well, making random shapes, I mean, I guess that's generally what I do because I don't I just like try whatever. But in this case, columns do work. Of course, they don't always work, but columns do work in this case, which is I think really cool because when I was doing this, I didn't use columns. I just did something crazy. Yep, very easy. Let's see this one. Actually, Let's go to something a bit harder. Okay, let's try this one. So this one is actually a lot more interesting. Yes, I can change the map. It is, yes, I have magic powers. But do you think this one, like, we can try to do this one?
It looks impossible, but it only looks impossible.
Well, actually, well, okay, it is impossible. We can see that. Yeah, so this purple star in these sort of programs means that it is impossible. But can we find a sort of easy, like a proof as to why it's impossible without trying every single possibility? Why do you think this one would be impossible? Just using like, I guess, logic.
Well, making random shapes wouldn't help because even if you did like something like 3 and a 2, it wouldn't work
Mhm.
because there's like too much yellow because the yellow's like in
Yeah.
like pretty much every spot and you can't go diagonally.
Yeah.
So yeah.
Yeah. So like, even like, it's not like, we can have a lot of yellow, and we can still win, as we demonstrated before. But in this case, because the greens are too spread out, that means that the only way we can create a like sort of group of 5 with green is by doing something like this, right? Is by taking up the center. But this means that we can't connect any of the other ones pretty much. Well, actually we can, but like, after something like this, after connecting some of the other ones like this, now all of the rest of the green are forced to be wasted. And the amount of green that is wasted is necessarily going to be quite a lot. And even something like this would be impossible because it would leave so many on this side and not a lot on this side. So while that's not a very it's not very good. It's a failure. But I think something like this would be a success for democracy, I guess, in general, because that's how you because now it's fair. The rightful winner wins.
So what level we're doing this level? What
Mhm.
level are we going to do now?
17.
Okay.
Well, actually, I think you guys have a pretty good grasp on like this sort of idea, but I think we should try something kind of harder and more realistic. Because in real life, sorry, because in real life, like, it's not just like a bunch of squares on a map, right? Each square can have so many people inside it, and not everyone votes the same in each square, right? So why don't we look at another sort of options. Okay, so why don't we have a look at another kind of way of looking at this. So sorry, let me just color. So can everyone see this from my iPad? So in this case, instead of having just like a bunch of squares like that are all willy-nilly, like just all simple, we have all of these squares. Oh, why is my iPad? We have all of these squares that are sort of like, you have mixes between the red party and the blue party. So in this case, we have 65% over here, like this. And we have like all of these mixes. So how can we group these squares into a way to figure out how we can allow blue to win? Because like, we can see that in this case, like, it seems like red is actually winning quite a lot, right? You can see they have all these 90s, while blue only has like these are the only majorities that blue has. But
Oh,
can anyone think of a way to actually allow blue to win?
but wait, are we grouping them by 3?
Oh yeah, sorry, we're grouping them by 3. I should have made that clear. And also, each square has the same population, so we're just gonna make that assumption. Actually, I think this would be a better way to represent this. So each square just has 100 people, and it's like this. So, and we just want to group them into 3 together.
Mm.
Yeah. So in each district, we will just add up each one, and we can apply the same rules as before, like just the same. So first of all, I think we can try to just pack. As blue, we can just pack all of those reds together.
Ooh, wait, I know. We could pack all the 90s and 95s in one with the with
So packing these,
mm-hmm.
yeah, say that's quite packed.
But can we go diagonally in this one or no?
Yeah, we can't go diagonally in this one. It would be interesting if we could. Yeah, we can try like diagonal ones as well to see how we can do this. But for now, let's think about how we can maximize the wasted votes.
Wait, so are you doing it diagonally?
No, for now we're not going to do it diagonally.
Mm.
Later we might try. So for example, can anyone see a district where a way to draw a district where all of the blues win, like a district of 3?
Well, and then I want to say like the 30, the 50, and the 65. But I don't know if it what the like sums are and like what's
Oh
the-
yeah. Yeah, sorry. Maybe I should have made like the sums a bit easier to calculate in your head. But we can also easily just look at it like this, because we can see that both of them have this sort of 50 attached to it. So this in the end doesn't really matter, this district, because they add the same amount to both sides. It doesn't really matter, right? Because, right, so all we need to look at is who gets more on these two. And since it's pretty obvious that this 70 lead is bigger than the 65 lead, we can see that, yeah, you were definitely correct. This is a pretty good gerrymander, and you have just annihilated all of these votes pretty easily.
and
And
then the last 3.
the last 3 as well. Yeah, we can also see this sort of similar effect. You're gonna have to actually add these by hand this time, but it is pretty clear that 90 plus 30 plus 40 is 160, and the Republicans, or not the Republicans, the Red Party has gotten only 140. So in this case, we can see this quite clearly, that we can just gerrymander our way to winning this election. So in real life, of course, it would have percentages, and not every square would be the same. However, in that case, like, we won't really be able to do it by hand, and it would require way more just like calculations, way more like stuff, and generally speaking, computers would be used. But I think this is a very good like introduction into the ideas of gerrymandering and how our democracy can be crushed. But I just wanted to talk about just one last thing, another way that we can sort of cheat elections just before we go. So in this case, we have, instead of drawing the districts ourselves, we have all of these districts already drawn. So you can think of this as states. This is sort of like the, so yeah, so Olivia says Joe Biden wins, right? But the thing is that this is actually for congressional offices, presidential offices. This is what is actual, this is what the presidential election actually looks like. These are pre-drawn because if you think about it, in the US, we have all of the states that are pre-drawn. All these state boundaries are pre-drawn. We're not going to be drawing these state boundaries ourselves. And all of these states, we know how some states will vote. For example, if we have something like this, we can see that, for example, California generally votes Democrat. Well, for example, something like this, like I don't know, some like like Oklahoma or whatever generally votes Republican. So in this case, we have sort of campaigns. We can go to a certain state and campaign in that state. And when we do that, we can raise, for example, if we campaign in this state right here, we can raise the amount of votes that we get by, say, 10%. Like, because when you campaign, you can get people to like you more in that state and you can get more votes, right? So when we do that, we can let's ask, which states should we vote for? I mean, not vote for, which states should we campaign in this case? If we campaign in certain states to win, which states should we campaign in? If say we are red.
You should probably do it on to be honest, none of them, because some of them would be wastes. I mean, I guess we could do the 51, but that's like it, because the other ones would just be a tie or just completely useless.
Yeah, so for example, if we campaign here, then it doesn't matter because we're gonna win the state anyway. And if say we campaign here in this 80-21 state, then it still doesn't matter because we're gonna lose that state anyway. So that's why it matters to campaign in the states with a very close one. And also we can also campaign in this one, right? If say we are red, because we can get up to 55%, and that would be sort of like and also remember, actually, no, that's wrong, because when we campaign for 45%, we reduce the amount that the other people get as well, right? Because if we get 10% more votes, the other people will lose 10% because it's it has to add up to 100. So campaigning in this state would also help as well. So now, does anyone like sort of see what these sort of does anyone know what these sort of middle states are called? These ones over here in at least American politics. This is very political. This is why am I bringing math into politics or politics into math? But does anyone see what those are?
What do you mean?
Yeah, okay. So maybe so these states in the middle where they're very close are called swing states. And those states have very close elections. Like they're very close. Everyone is extremely like that's where campaigning does have an effect. So like in this, yeah, so that's where like the presidents generally go to campaign, right? Does that make sense? Because, and the reason why they're called swing states is that they swing from election to election. So they're very close. These states actually like they will swing from party to party. Whereas other states like this one, they won't really swing. Like it doesn't really matter. I am Asian. I don't know much about American politics. Okay. It's kind of okay. I'm also Asian. Unfortunately, I mean not unfortunately. Yeah, I'm also Asian. So, but I think it's important to everyone's Asian. I think it's important to know why, for example, Joe Biden and Donald Trump they never come to, say, California, really. They don't really come here to campaign. And they usually campaign in states like Ohio, Florida, all of these states that are very close, like these. And this is
Missouri,
why.
like the states in the like middle of the United States.
Oh, the states in the middle of the United States are not necessarily the swing states. They are just, I just put them in the middle, just for no reason. This is kind of arbitrary. This is just random. But they just go to states where there's a very big mix between people who vote for different parties. So does that make sense? So that they can get just those additional votes for the overall election. And that is how they win. So because investing in these would just waste additional votes. And you want to just invest in these in the middle to have as few wasted votes as possible. And that is why oftentimes presidents will try to prioritize certain states, because those are the states that they need to get reelected or get elected in the first place. So does this make sense? I think a lot of this is actually quite important to know just for American politics in general, but I think it's also just a very interesting experiment into logic. And maybe if any of you try to run for office, you can gerrymander your way.
Wait, why are all the states all square-like?
Oh yeah, the states are not. I just sort of made this for the sake of explanation.
It looks like something like texture. But what?
Oh, Tetris.
Yeah,
It does.
you copied it from a game.
Yeah, I mean, because I was using this app that had squares, so that's why I did that. That's why it's all square like. But anyway, I think it's 8:04 now, so well we gone overtime, but I think it's cool. So guys are welcome to leave. If you want to stay, if you think this is really interesting, want to discuss this further, you can also stay. But for now, yeah, the sort of meeting is over.
Wait, what do you mean we
Thanks.
could stay?
I mean, if you really like it, you can stay after class. I mean,
And do what?
I don't know if you have any questions, basically.
Okay.
If you have any questions about the topic or about anything in general, like about the course. Yeah. Anyway, so thank you guys for coming. Yeah.
Wait, I do have